Welcome, everyone. Thanks for listening. I just want to give a quick recap of what the F value is, or the observed F, the F critical, as well as the P value, since I've had some questions on that. Um, so that's what this slide is about. And so there's only one other slide. I'm going to go over everything in one shot. So feel free to pause, take notes, listen to it again as needed. And hopefully this will help clarify what these three items are. Okay, so starting with the F value, or the observed F. This is the number you get from your calculations. It tells you how much the group means differ compared to the variation within the groups. So think of it like this. Are there differences that we see between the groups? And are they big enough to matter? Or are they just due to random chance? The F critical, that's the cutoff point from a chart. So it's the value your F has to essentially beat in order to say, yes, the group differences are significant. If your F value is larger than the F critical, then your results are significant, which is where the P value comes in. This is the likelihood or the probability that your results happened by random chance. So a smaller P value, typically less than 0.05, means that there's a very low chance the results happened randomly. So we consider the finding to be meaningful. So let me break it down one other way with this chart that will hopefully help. So the F value. So what it is the result of your ANOVA calculation. What it tells you is how much the group means differ compared to the variation within the groups. Think of it like a signal to noise ratio. A higher F value means a stronger signal, bigger differences between groups relative to the noise, which is random variation. The F critical value, what it is. The cutoff point from the F distribution table based on your degrees of freedom and chosen significance level, usually 0.05. What it tells you is how big your F value needs to be to say the group differences are statistically significant. Think of it like a threshold. If your F value is larger than the F critical value, then you have enough evidence to say the differences between groups are not just random. Okay, so P value, what it is. The probability of getting your observed F value or more extreme if the null hypothesis were true, if there were no real differences between groups. What it tells you is whether the results are statistically significant. Think of it like a percentage chance. If P is less than 0.05, it means that there's less than a 5% chance the results happened randomly, so that you can then reject the null hypothesis. So let's look at an example using the F value in the real world. So let's say you're a researcher studying which of three teaching methods is most effective. You randomly assign 30 students to one of these groups. Group A would be a traditional lecture, Group B, an online learning, and Group C would be interactive group activities. After a few weeks, all students take the same final exam. You want to know, do the average test scores differ significantly between the three teaching methods? So you would run a one-way ANOVA. Okay, so the results, hypothetically would be the F value would be 4.75. The F critical value from a table based on degrees of freedom would be 3.32, and our P value, let's say, would be 0.02. The F value of 4.75 tells you that the variation between the group averages is 4.75 times greater than the variation within the groups. Since 4.75 is greater than 3.32, which is your F critical, you have enough evidence to say at least one group is significantly different. And because the p-value is 0.02, which is less than 0.05, the result is statistically significant. So the test scores between the three teaching styles differ enough that it's very unlikely this happened by random chance. So you'd conclude that at least one of the teaching methods works differently than the others. Okay, so that is my explanation of the F value, the F critical, and the P value. I'm hoping that this helps, and feel free to reach out as always with any questions. And thank you so much for listening.